There's four main kinds of problems in this section, and let's just start doing them. The first problem is the absolute value of x minus 1 equals 4. And before we start that problem, there's something you need to know. It's not good enough just to ignore the absolute value signs and write this down and solve it and get x equals 5. That will not work. Don't do that. To understand the idea, let's replace x minus 1 temporarily with a question mark. And let's figure out with a number line what's going on. If x minus 1 is a question mark, then the absolute value of question mark has to be 4. So where can the question mark be on this number line? It can't be in here if its absolute value is going to be 4. The question mark has to be either here or here, because 4 and negative 4 are the only numbers that have an absolute value of 4. Why do they have an absolute value of 4? Absolute value means the distance from 0, and 4 is 4 spaces away from 0, and negative 4 is 4 spaces away from 0. So yes, the question mark could be 4. In other words, x minus 1 could be 4. And you add 1 to both sides and you get x equals 5. But also the question mark, x minus 1, could be negative 4. And you add 1 to both sides and you get x equals negative 3. Lots of people can find the x equals 5. Not very many people find the x equals negative 3. Notice both of them check if you put them in here and then take the absolute value. So you could write this or this. The book tends to like putting these in set notation, but I don't know that that's super important. You could just write them both down and it would be fine. Now, again, let's make the x minus 1 be a question mark. And let's put a negative 4 and a 4, and let's see what we have. It says the absolute value of the question mark has to be smaller than 4. In other words, its distance from 0 has to be smaller than 4. Well, that means it's somewhere in here. These are the places that x minus 1, that question mark, could be. It's got to be in between negative 4 and 4, so the slickest thing to do is to put the small number negative 4 on the left, the large number 4 on the right. Since this is less than, we'll put in a couple of less thans and then stick the unknown thing, the x minus 1, in the middle. This says that negative 4 has to be smaller than x minus 1 and x minus 1 has to be smaller than 4. Now it is acceptable to do something to all three parts, like add 1 to all three parts. It's a very neat trick. This is the fastest way that I know of to do this problem. And so we have negative 3 is less than x and x is less than 5. Now the directions might say to write this in set builder notation. Well, fine. We can have the set of all x's such that this is true. They might say to write it in interval notation. Well, fine. There it is in interval notation. They might say write it in a graph. Well, fine. Here it is in a graph. So all those are possibilities. Now the next problem. Here really does kind of the same thing, except there's a little bit of a difference. If we treat the x minus 1 as a question mark, how can its distance from 0 be greater than 4? Well, it could be over here or it could be over here. It can't be in the middle. And so we could have that x minus 1 is less than negative 4. Or x minus 1 is greater than positive 4. Solving this one by adding 1 to both sides, we get x is less than negative 3. Solving this one by adding 1 to both sides, we get x is greater than negative 5, and there's an or. So again, if we're asked to graph those, what would those solutions look like? Well, there would be something just happened. So I made a mistake right here. We have x minus 1 is greater than 4, and I put x is greater than -5. That should be 5. So we want to graph these. X is bigger than 5, looks like this stuff. And x is smaller than -3, looks like this stuff. If they ask for set builder notation, it would be the set of all x's such that x is less than -3 or x is greater than 5. And if it asks for interval notation, it could be the interval that goes left forever and comes up to -3, and that is unioned with or combined with or ORed with the one that starts at 5 and goes up forever. So again, this is interval notation, this is set builder notation, this is a graph. Now the x minus 1 equals x plus 2, I'm going to move this around a little bit. So the absolute value of x minus 1 equals the absolute value of x plus 2. There's two possibilities here. One is that x minus 1 equals x plus 2. But the other one is that x minus 1 equals the opposite of x plus 2. That's the way two absolute values can be equal. For instance, if I have the absolute value of 6, it equals the absolute value of 6. It equals the absolute value of itself. But the absolute value of 6 also equals the absolute value of the opposite of 6. So when you're dealt an equation with two equal absolute value signs, one equation that you get is the same equation without the absolute value signs. That one's pretty easy. But the other one, you have to take the opposite of one side or the other, and I take the opposite of the second side. When we solve this, we take away x from both sides and we get nonsense. -1 can't equal 2 ever. So this does not lead to any kind of a solution at all. What about over here? Well, we distribute the minus sign to the x and to the 2. Let's add an x to both sides. We get 2x minus 1 equals -2. Let's add a 1 to both sides and we get 2x equals -1. And divide both sides by 2 and we have x equals -1/2. And so you can see that x equals -1/2 is the solution to this equation. So those are the examples. I think that's probably good enough. If you looked at some of the software examples, this will probably help you enough to be able to do the problems.